Hello everyone and welcome to this video. So today we're going to interpret the results of our statistical analysis, the effects of study hours on academic performance using SPSS is what we have been doing all along. So before we begin, I would like to note that the dataset that was used for this analysis is strictly for learning purposes. So the goal is to help beginners understand how to interpret SPSS output. And because of this, we will notice some relationships in this dataset are much stronger than what researchers would normally observe in real-world educational studies. So to begin with, we'll look at our descriptive statistics table. So descriptive statistics will provide a summary of your data in terms of averages, minimum values, maximum values, and standard deviations. So as for a sample, we had 100 students, and the average age of the students was 21 years old, followed by the average study duration, which was about 4 hours 30 minutes per day, and the attendance was 81.54%, followed by the average score, which was 71.3%, and lastly the academic performance, which had an average of 71.82%. So what this tells us is that a typical student in our dataset studies for about 4 hours each day, and this helps them achieve an academic score of approximately 72%. So descriptive statistics will not really test the relationships, but they'll simply help us understand the characteristics of the sample before we move forward to the more advanced analysis. The next thing we have is the frequency tables. So we examined the categorical variable using frequency distributions. So frequency tables will show you how many participants belong to each category. For instance, gender, the sample consisted of 51 females, as shown here, and 49 males, which means the dataset is almost perfectly balanced between male and female participants. So for year of study, we had 30 students who were in year 1, 23 students in year 2, 20 students in year 3, and 27 students in year 4, as shown in the table. And then the next thing we'll look at is the Pearson correlation analysis. Now, the purpose of this analysis is to determine whether two continuous variables are related. So in this study, we wanted to know whether students who study more tend to achieve better academic performance. The correlation coefficient between hours and academic performance is 0.977 with a significance value of 0.001. So a correlation coefficient ranges from -1 to +1. A value close to +1 indicates a strong positive relationship, whereas a value close to -1 indicates a strong negative relationship. The value near 0 indicates little or no relationship. So because our correlation is 0.977, this shows us an extremely strong positive relationship between study hours and academic performance. In other words, the students who study more would tend to achieve higher academic scores. However, this is where we need to be realistic. A correlation of 0.977 is unusually high for educational research because in real studies, academic performance is influenced by many factors such as motivation, intelligence, teaching quality, stress levels, maybe learning style, sometimes family background might be a contributing factor. And because this dataset was designed for teaching purposes, these are some of the examples of the relationships I mentioned earlier that might appear stronger than research typically observes. Well, nevertheless, the interpretation remains the same. We observe that study hours and academic performance are strongly and significantly related. The next thing we'll look at is the simple linear regression. So after establishing that indeed a relationship exists, we used simple linear regression. Correlation tells us whether variables are related, but regression tells us whether one variable can predict another variable. So in this analysis, study hours were used to predict academic performance. When we look at the model that was produced, we see that the R-square value is 0.955. This means that the study hours explained 95.5% of the variation in academic performance. And the regression model was statistically significant with the p-value of 0.01 as indicated in the table below, showing the coefficients. On top of this, the regression coefficient for the study hours was 7.140, and this means that for every additional hour spent studying, academic performance increased by approximately 7.14% in their overall grade. So in real-world research, this is exceptionally strong, and it's uncommon for one variable alone to explain over 95% of academic performance. So this outcome is useful for demonstration. However, researchers would normally expect a much lower R-square value, but the important conclusion is that the study hours significantly predict academic performance. The overall model produced an R-square value of 0.972, and this means that the three variables, that is the study hours, attendance, assignment scores, explained 97.2% of the variation in academic performance. This model was also statistically significant because the p-value was less than 0.001. When we look at the coefficients table, all three predictors were statistically significant. So when we look at the study hours, for example, we see that the coefficient is 3.272 and the significance level below 0.01. Attendance had a coefficient of 0.251 and a significant level of 0.10. Assignment scores had a coefficient of 0.470 and a significance level below 0.01. This means all three variables contribute to predicting academic performance. Next, we conducted a one-way ANOVA. The purpose of ANOVA is to determine whether the average academic performance differs across multiple groups. So in this study, we compared academic performance across the 4 years of study. So the ANOVA produced an F value, shown here, of 0.916 and a p-value of 0.436. So because the p-value is greater than 0.05, this result is not statistically significant, which means that there is no evidence that academic performance differs between first year, second year, third year, and fourth year students. Lastly, we performed a chi-square test of independence. The purpose of this test is to determine whether two categorical variables are associated. So in this case, we examined whether study hour categories differed according male and female participants. The chi-square test produced a p-value of 0.790. Since this value is much larger than 0.05, you agree with me, the result is not statistically significant, which means there's no evidence of an association between the gender and study hours category, meaning male and female students appear to have similar study patterns within this dataset. So in conclusion, what have we learned? This study helps us see the different statistical tests and how they can be used to answer different research questions. Descriptive statistics summarized the sample. In addition, frequency distributions describe participant characteristics. The Pearson correlation showed a very strong positive relationship between study hours and academic performance. As for simple regression, we saw that the study hours significantly predict academic performance. As for the multiple regression, we saw the study hours, attendance, and assignment scores and how they jointly predict academic performance. As for the ANOVA, we saw no significant difference between the academic performance across years of study. And finally, the chi-square test found no association between gender and study hour categories. So, in a nutshell, the results suggest that students who study more, attend classes regularly, and achieve higher assignment scores tend to perform better academically. However, because this dataset was designed for the purpose of learning, some of the relationships are a little bit exaggerated because they're much stronger than real-world typical results. So in the next video, we will look at how we can produce graphical representations to help us put our work into much easier and interpretable results. So thank you for watching this video. I hope it was helpful, and I wish to see you in the next video.